let's get this started. What ant lives inside a car? What type of ant lives inside a car? Coolant? That was actually my son. I was working on the car and he came up with that. So I'm training him well. Anyways, here you go. A large jar. If you don't know what coolant is, maybe I should step way back, right? Coolant is what's inside your car and it cools. It just keeps flowing. That's why you have heat in the car, right? It cools the engine. And anyways, don't drink it. It's really bad for you. A large jar contains many jelly beans. So there's 53 beans that give us the total, but they also give us the breakdown of what's inside the total, right? So that's kind of like a bit of a bonus. Based on the beans you drew out, okay, what are the odds in favor, right? Odds in favor of jelly bean being red. So that means that red will be on the still laughing. Red, not red, because it's so cheesy. Red, not red. So you start with this 16, and on the other side, you can do whatever works for you, but I would go total minus 16, right? So it's 16 to 37. Okay. That's fine. It's fine. I'm usually a little bit more forgiving if I see, okay, you understood what was happening. You maybe, got the number wrong, right? You subtracted and you got it wrong, right? Because I see the work, but that's fine. 16 to 37 is all you need to see. I need to see. Based on the odds, again, based on the previous answer, I think that's what it's supposed to say, or what's above. What are the odds against a jelly bean being black, right? So because this word is there, you kind of have to think of, right? Black jelly beans there, and this would be not, right? So we need to focus on the event itself, like what is it against, right? So you got to put 9 goes here, and this side would go 53 minus 9, okay? So 9 over here and 44 goes on the left side. So this is the order matters. Having it in this order matters a great deal for us, right? The experimental probability that a jelly bean is red, or sorry, here, this one. Experimental probability. Don't worry about this word so much. We're talking about soon, but right now just focus on probability. Probability of red. You don't have to have this part, but you have 16 out of a total of 53. So that's what I need to see there. If I didn't give you this total, then obviously you would have added all of these up and you get 53. Okay. Given that let's say you eat on a bigger sample, there's 2,500 jelly beans. How many would you expect to be red? I already got you to do the work before. So this is actually a prediction. So it's 16 out of 53 times the 2,500 jelly beans. So divide this, multiply by 2,500. You get 700, 754, 71, and it keeps going. That is approximately 754 or 755 beans, right? Let's keep going. So everything is 1 mark so far. A sports betting site says that the odds, here it is, odds in favor of the Jets winning. That is the event in question here. In favor of them winning is 1 to 25. Because it's worded this way, that is win. This is not winning. Okay, that's simply put, right? So what are the odds against the Jets winning the Stanley Cup? You just flip that. It's all you need to do, right? Odds in favor is 1 to 25, odds against 25 to 1. Based on these odds, what is the probability the Jets will win the Stanley Cup? So probability of winning, we know that, right? The 1 represents the win, and the bottom would be 1 plus 25. And you might think, I got 1 over 25. It's very close, right? No, not in this unit. It makes a big deal, this being at 25 or at 26. It's a big deal. So if you have 25, then it's wrong. It'd be minus 1. Okay? So make sure you get that right. Remember, when you're going from odds to probability, add them up. You're going to have to add up the two numbers to put it in the denominator. Okay? Next, a weather forecaster says that the probability of rain tomorrow is 60%. What's the probability that it does not rain tomorrow? I would hope you know that it is 40%, right? Like it happening and not happening, remember? 100%. I'm being very annoying about that, but that's really just a very important concept. What are the odds in favor of rain tomorrow? So here, you kind of just have to know, okay, let's go back to this one. You could write it 60 to 100, right? 60 over 100, this number right here. So odds in favor of rain. That means that rain goes on the left and not raining goes on the right. I know that 60 is rain, therefore 100 minus 60 is on the other side. So that'd be 60 to 40, right? Or 6 to 4 if you divide them both by 10. Or if you divide them both by 20, that'd be 3 to 2. That's also correct. I wouldn't simplify unless I ask. Because if you get it wrong, then I need to take marks off, right? Okay, so this page is 8, right? 1, 2, 3, 4, 5, 6, 7, 8. There's only one page, so that's it. It's out of 8. So we'll take our booklets out. It's very good to have examples that are right. Okay, not just you work through it, but that are also good, because probability and odds, you just need repetition. Okay, so let's go to page 22. So I might race through some of them and walk you through it. Okay, the probability of going blind after laser surgery, eye surgery that is 1 in 5 million, 1 over 5 million. State the odds of going blind, right? So going blind. So blind, this is page 22. Blind, not blind, right? So in this case, it would be 1, right? Because it's saying the probability of that happening is 1 over 5 million. So this would be 1 to 5 million minus 1. So it's 1 to 4 million. So this would be very important to see all those 9s there, okay, to get this right. Okay, odds against going blind. So we would just flip that, right? We already have the answer. There we go. State the probability against going blind. Against, right? Couple of ways you can do that. Remember, it's all connected. I'm going to go like this. Probability of everything going well, basically, right? We are back to probability, right? So we are back to the 5 million. You can add up the numbers and get the 5 million, or you can just go to the original. And over here, right, not being blind after is right, 4,999,999. So that would be your way of answering that one. So I'm mixing up probability. Mixing. If you want a percentage, yep. If you round to 2 decimals, yes. So don't do that, then just keep it as a fraction. If the numbers are very weird, keep it as a fraction, right? Yeah, because it's almost 100%. All decimals, that's right. So in this case, you would want to avoid, I would not ask you to state that as a percentage. I wouldn't do that. Right? 22 is good. Lots of space for just two numbers, right? So that's how the test is going to be. There's going to be a lot of marks here and there, but it really is done very quickly. Page 23. Here it's going to go a little weird with the numbers, okay? So you got to follow along, be prepared for it. Determine which event is more likely to happen. If you're asked to do something like this, I'm going to highlight what I will suggest you do. Determine the probability and specifically focus on percent. Okay? That's what you want to do. So turn both of these odds, we're going to turn that to probability, right? So there's the higher value indicates the higher chance of it happening, basically that it's more likely to happen. So the odds of being attacked by a shark is 1, 2, 3 million and something. I looked this up on the internet. I don't know how they determine that, but hey, we'll roll with it. The odds of coming into contact with hornets would be this. Okay, state the probability of being attacked by a shark. So probability shark. Watch what you're going to do here. You're going to go 1 over, show the work, right? 1 plus 3,748,067. And this is where it's going to be weird. It wasn't the greatest example to start off with, but I think you should be able to. I'm going to make that 8 stand out a bit. And let's go comma, and let's get the decimal going here. And I'm going to write down all decimals actually, just like Victor was suggesting earlier. So remember, our main goal is to determine which one is more likely to happen. So see how that's your decimal? I'm going to multiply that by 100 and say that this is 0.12340 zeros, 2668%. I'm going straight to percent because the decimal, you'd have 6 zeros in there. Enough of that, right? So just write that down. And let's do the same thing for this one. Probability of being attacked by hornets. That's going to happen soon. I'm going to always have some coming in here. So cabin life is pretty tough. Okay, so but don't worry, I'll take care of it. I'll get rid of it. 1 plus, so I'm adding, going back to the odds, I'm adding those two numbers, and I put the 1 on top. And that's 1 over 54.94. I'm going to emphasize that 4 a little bit. Page 23. Okay. Let's turn that into a percentage, comma, 1 divided by 54.94 times 100, 0.001848633%. Why do you do that, right? I just do it for this particular example. Like on a quiz or a test, you'll never have something like this. It'll usually be reasonable. AC, you might have something like this. But you should recognize that between these two numbers, this one is greater. This is a bigger percentage. Even though they're both very small, this is greater. Okay, so being attacked by hornets, comma, since the probability is greater. Okay, the percentage is greater, and so forth. Next, we have the odds of Xavier being late would be 4 to 9, while the odds of Nina being late 5 to 14. Go ahead. Which one is more likely to happen? Which one is more likely to be late? Okay. See how I sneak in being on time, or being late, I guess, in this case. So just if I ask you this, just a big question, right? Xavier here, Nina here, okay? And so expect this on ACs. Probability of being late here would be, let's add the numbers up. And 4 means, the way it's worded, we know that 4 is being late. Should we write this down? Uh, 4/13, okay? Turn that into, I'm going to go straight to percent. Right? That would be, comma, 30.77%. Okay. Let me just bring this down. Probability of being late here would be 5 over 5 plus 14. So don't guess. Okay, don't just say, oh, that one looks like it's gonna be it, right? Show me the work that goes with it. And so that would be 5 over 19, and some of you did this already, so you just along for the ride, right? Multiply that by 100, and I get 26.32%, like that. Okay, so you would have to say in this case, right, more likely to be late. Clearly indicate that Xavier has a greater chance of being late. All right, 24. How many of you finished 24? I see so many hands. Thank you, Mats. So many hands up. So if you're not done 24, I want you to try 24 right now. And the 24, I would say, is easy, right? 25 is when it gets a bit more challenging, including this one here. Watch this on page 25, right down the middle. There's Sisler's odds, there's Kelvin's odds, and there's Daniel Mack's probability. So which one of those 3 schools is more likely to win the tournament, right? So you're going to have to compare 3 things as opposed to just 2. Right? So 24 and 25, I'll give you time right now. Please use it, right? We all know that when we go home, we tend to do other things, right? So use class time to do 24 and 25 right now. I'm going to get started. Page 24. Make sure you write this down, right? So we're talking cards, right? We'll talk 52 cards, if it's ever talking about a die, it doesn't say anything, and it's just six numbers, right? 6 cards, no jokers, right? And so just keep that in mind. Drawing a red 7. So probability of red 7. There are 2 red 7s out of 52. Probability of drawing a jack, right? There are 4 jacks in a set. So I would say turn them both into percentages. This would be 3.85%, and this would be 7.69%, right? So you say this is more likely to happen. Next, drawing a face card or rolling a 5, right? So probability of face, should all know that there are 12, right? 12 out of 52. So in this case, there are no odds, right? I could have given you some odds to convert, so be ready for anything. And so this would give you 23.08%. Whereas probability of rolling a 5, there's only 1 5 out of 6 options. So that'd be 16.67%. So this one is more likely to happen. Okay. Drawing a club face card. Okay. Probability club face. How many club face cards are there? 3, right? If it's just the clubs, then there's only 3, right? Does that make sense? Ace is not a face, yeah. But it's a club, so you got it just down to clubs, and there are 3 in that suit. Okay, so out of 52. So we have 5.77% for that, and then probability of spinner landing on yellow. We're talking about this one. You might recognize that one. Hey, how's it going, spinner? 1 out of 8, right? So that's 0.125, which is 12.5%. Okay, so this is more likely to happen. So if you wanted to, which one is better, your better option, you would pick, hey, I'd rather spin on that spinner for the money, right? Higher chances of winning. If yellow is the one we're after. Rolling a multiple of 3, so multiple of 3, standard die would be 3 and 6, right? That's all we have, 2 options. So probability of M3, that's what I usually call it, is 2 out of 6, right? That's 1/3. That's 33.33%. Versus probability of green. In this case, we have 2 greens, right? So that's 1/4, which is 25%, right? So this is more likely to happen. More likely to happen. Drawing a red card or the spinner landing on red, right? So probability of red. From a deck of cards, there are 26 out of 52 are reds, right? That's 1/2. That's 50%. I go equals because it's exactly equal to, you could have gone equals to 50% as well because there are no rounding issues there. But then probability of spinning that spinner and getting it on red, there'll be 3 options out of 8. And that gives you 37.5%. This is more likely, right? More likely to happen. Okay. Keep that in mind. Let's go to 25. That'll be it. Once I'm done with 25, we're done for today. Make sure you follow along on 25. Okay. The Bombers have a 45% chance of winning the Grey Cup, while the Edmonton Elks have a 7 out of 9 chance of not winning the Cup. What's going on there? Write both probabilities as odds for and against winning. So I purposely tried to get you confused here. That was my intent. Okay. So Bombers, let's see what's happening here. Bombers have a 45% chance of winning. So probability of winning would be 45 out of 100. That's how I would write it. Okay. Rewrite it like that. So odds of winning and odds, sorry, just two, odds against winning. Okay. So of winning, you'd go 45, and on the other side, you would have 100 minus 45. See how that works? If a fraction, you turn it like this. So that'd be 45 to 55. And we'll just leave it like that. I know I can reduce it. It's fine. Odds against, we'll just flip this, right? You can just go ahead and flip it because you have it already. So this would be the odds against winning. So if you could divide them, right, it would be 11 to 9, right? 11 to 9 or 9 to 11. Okay. Next you have Elks. That's probability. What does it say? Chance of not winning, right? So they're actually giving you probability of not winning. That's 7 over 9. So you got to watch out here. Odds of win or for winning. Odds against. Okay, odds against there. I'm going to do this one first because this is, I have to be careful here. If this is probability of not winning, then what is probability of winning? Maybe I'll do it this way. 2 out of 9, yes. How about we work with this one? So that means that if it's odds of winning, then wins come first. And on the other side, you'll go 9 minus 2, right? So it'll be 2 to 7. Page 25. 2 to 7 like that. And therefore, odds against would be 7 to 2. 7 to 2. How about this? If you like arrows, right? That's where we got that one from. Then I went to this, right? And from there, I went and filled in the odds, right? And these are odds against winning, which is another way of saying the odds of losing, right? So you have losing, winning like that. So if your head is spinning, I apologize. But just be careful when you read it and see what makes sense. I could have asked you which one is more likely to win. This one is already as a percentage. Just turn that, right? You would actually take this one, turn that into percentage, and see which team is more likely to win, right? So if that happens, you know what to do. Next, I'm going to show you how to do this one. Which school has the best chance of winning? So we're talking about the likelihood of winning. So we're going to go Sisler. has a 9 to 17 odds, right? So probability of winning would be 9 over 9 plus 17. That turns out to be 9 over 26. That turns out to be 34.62% chance. Okay, so we'll leave it at that. Calvin? Probability, what does it say? The odds in favor of Calvin losing the tournament. Odds in favor of what happening? Losing. So that means that this is losing. This is not losing. Okay, that's what that is saying. The way it's worded, right? Odds in favor of what? Of losing. So losing comes first. We want the probability of winning. So you know what you can do right off the bat is add these up. Go 23 plus 12. And not losing, this 12 here is what you want to put here, because not losing is winning. Okay. So we have 12 over 35. And that gives you 34.29%. Very close, but Sisler still has a little higher chance of winning, okay, based on this. Next, the MCI. Some of you are like, we have way bigger chance than they have, than Calvin. It's not even close, right? I just made this up, so don't take it too serious. 4 over 15, it's already, right? It's already chance. It's already a probability. 4 out of 15 games are wins. So that would be 26.67 if you turn that into a percentage. So Sisler, most likely, right, to win tournament. I don't know how they come up with this one here. Struck by the odds of being struck by lightning. No idea, but I just got it off the internet. We're going to roll with it again. State the probability against being struck by lightning. So let's see here. Odds of being struck by lightning. That means that one person gets struck and all these people do not. So probability against being. So basically they want this probability of not being struck. So that's 11999, right? 11,999 over 12,000, right? Because we add these up. That's it. We're just going to leave it like that. Odds against being struck by lightning, just take that one. And I would expect you to just know that you have to flip it. Flip original. And one more, and then we're done. Out of 850,000 people, how many are likely to be struck by lightning? This is a prediction. So we're going to go 1 out of 12,000, right? Because one person gets struck out of 12,000 if you add this up. Times 850,000. That gives you 70.83, which is approximately 70 or 71 people. That can't be. That's way too much. It's not as frequent as that, but anyways, we're just going to roll with it. This here is 1 plus 11,999, just in case you're wondering, how did I come up with that?